All right, in the last video, we kind of finalized the segments we're going to use for this image, and I have those loaded up here in QGIS, so you can see that I have my image and my segments are transparent over the top of that. And so you can see that we kind of got these segments to match up with the features in our image, at least relatively well, so that we could then start classifying these segments. Okay, and you can see a stream coming right in there, which is kind of cool. So now what we need to do is we need to get information for each of these segments that we can then use in our training, so we can then use to attribute our training data. And so that's what we're going to do in Python in this part of our image analysis series. Oh, and that's my Anaconda prompt, not my script. Okay, so here's my script. All of this is up on the website, so I'll include a link to this in the description. You can copy and paste the code out of there. I'm going to clean this up a little. I'm going to get rid of all these segments except for the ones I actually want to use. I'm going to go into QGIS, and I'm also going to remove these so they don't have any errors when I try to write this file again. Okay, so what we really need is we need this segments object here that we get from running our slick segmentation algorithm. We don't actually need to save this to a raster to get what we need. So I'm just going to start adding my code in here, and I'll still save it to the raster just so we have it. Even though I already have it saved, I'll keep saving it. In case anything changes in the future, I'll still have that saved. And I'm going to name this segments final, so that when it does save, I know it's the segments I'm using for my analysis. Okay, and so now what we need to do is we need to get an ID for each segment. And I'm going to make sure I have some imports up here. I have NumPy imported, I have GDAL imported. I also need to make sure I have SciPy imported. All right. So we're going to get segment IDs, and that's going to just be mp.unique segments. Okay, so what this contains is the segments are just a number. It's a 2D array that has a number in each grid cell. Okay, and you can see that, you can't see now because I removed it, but you can see that in QGIS, how there are multiple cells that have the same number. We only want to get the unique values. So I had about 450,000 segments. So segment IDs is going to be a 1D array that has 450,000 individual numbers in it. It'll go from 1 to 450,000 basically. And I need that because then I'm going to group the pixels by the segment ID and get statistics about each ID. Okay, and so when I get those stats, I'm going to save them to a list, which I'm going to call objects because these segments represent objects. So we're going to make an empty list. I need to save the ID of each object, so we'll call object IDs is going to equal an empty list. And we want to loop through all our segment IDs. So for ID in segment IDs, we're going to loop through, and we want to get all the cells that occur within a given segment. And so to get that, we want to get our segment pixels. Okay, and if you remember, IMG contains all our data. So we're just going to be IMG where segments is equal to ID. Okay, so segments is going to be the same 2D shape as image. And so wherever segments equals ID, we want to get all the image values at that location. And so to calculate those statistics, I want to create a new function that will do this for me. And for now, I'm just going to throw this function right up here so that we can see it as we work. And so I'm going to call this segment features, and it's going to take segment pixels as an input. Okay, and so I'm going to get a features, which is just going going to be an empty list to start, and that is where I'm going to get the statistics out of each pixel, or out of each group of pixels, each segment group, and then at the end, I'm going to return the features. Okay, and in here is where we're going to calculate the statistics for the features. So, what I want to do now is just lay out the rest of this loop first of all. And so what I want here is this is going to be my ID features. So I guess this is going to be my, we'll call it segment feature equals segment features and segment pixels. That should be a lowercase f. Okay, so now I have that feature for my object. Well, let's call this we'll call this object feature. The features for the object. And so now I want to do my objects. I want to append the object features and my object IDs, I want to append the ID. So this will give me lists that match up, and make sure you spell append correctly, as I did not do it. So now we'll have a list that has all the features or the statistics for each object, and then we can link the ID up with that as well. Okay, so now what I'm going to do is we're just going to check something. And so when I get the segment pixels, I want to print pixels for ID, and I'm going to print out my ID, and then I'm going to print out segment pixels dot shape. I just want to make sure I get this shape right. What I think should happen, remember, image is a three-dimensional array, a three-dimensional matrix. So it's going to have rows, columns, and channels or bands. I think when I do this, what I'm going to get out is I'm going to get a 2D array that's going to have the segments, or it's going to have the rows and columns all lined out in one dimension, and then that will have, so that'll be my rows, and then it will have a column for each band. But I want to just make sure that it comes out like that. And so it's going to take a minute to run the segmentation because I have it running the segmentation every time here. And then it might take a minute to start looping through these, but we'll start printing these out. And maybe a better way to do this would be to run this just in an interactive session. We're going to do it like this for now. So I'm going to click run here. I'm going to pause the video after I click run until we get some things popping up, and then I'll get it going again. So I'll click run, and I'll pause the video while this goes. Okay, so it's going here, as you can see. We've got pixels for ID, and you can see that they're 2D. So we have all the number of pixels, basically. There's 302 pixels in that segment with 4 bands. So 4 columns, 1 for each band, for each pixel. Okay, so that's great. That's what I was hoping we'd get. So now I can just come over. I'm just going to stop this. We don't need this to continue running, so we'll stop it. It will exit. And you can see this is going to take a little while to run when we need to get all the information for these segments. But that's okay. Okay, so I'm going to hide this so that we can continue working on this. Okay, so we have this loop set up. This loop is working. Now we need to come into our segment features and actually get the information we need here. So we can get the number of pixels, excuse me, and the number of bands equals segment pixels dot shape. And so that'll give us the numbers of those we saw printing out on the screen earlier. Okay, so now let's loop through each band and get stats for it. So let's go for B in range and bands. And now we want to get stats. We'll do stats equals scipy.stats.describe, and here we're going to do segment pixels. We want all the rows, and then we just want it for this band. Okay. Now let's go take a look at the documentation for scipy stats describe. And you can see here we get the number of observations, which we don't need. We get a tuple with the min and max, and then we get the mean, variance, skewness, and kurtosis, which can all be useful for our machine learning algorithm. So we don't need an obs, we want min max, we want the mean, the variance, the skewness, and the kurtosis. Oops, it's my anaconda prompt again. So let's go ahead and get those in a stats list. And we can do that. We'll call this band stats. We'll get list stats.min-max, which was the first one. And then we also need to get list stats 2 to the end. When we didn't want 0, this is 1, which is going to be a tuple, so we'll make it into a list, and we're good to go. And then we're going to get the rest of the stats here. Okay, looks good. Oh, this parentheses, sorry, this needs to go here. We want to make the stats into a list, and then do that. Okay, good deal. Okay, now we need to do one more thing here, and that's if n pixels equals 1. So in this case, the variance, let's just type this in. In this case, the variance equals NaN because you can't get variance only 1 pixel. We're going to change it to 0. Because if we have NaNs, it's not going to be good for our classification algorithm. So band stats, the variance is going to be the third element equals 0. Okay, and so we're good to go there. And then we're just going to features plus equals band stats. We can get all the band stats added into this one list of features, and then we're going to return features back here, and that's going to give us a list of objects and a list of object IDs that correspond to each other. Okay, and so we should be all good to go here. So what I'm going to do is after we run this, I'm going to say we'll just do print created, and then we'll say when objects. So we created a number of objects with, and then we can do when objects 0. So it goes to the number of variables with variables. Okay, and what I'm going to do here now is I'm going to call this, let's call this obj start, and that's going to be time.time, so we'll see how long this takes, just so you get an idea. And then in time.time minus obj start seconds. And I'll hit enter here, so we put this on a new line so we can see it. Okay, so we're going to run this, and when it's done, it's going to print out how many objects were created, how many variables there are for each object, and then the number of seconds it took to run. So I'm going to click run here, verify that this gets started, and you can see it did, and then I'll pause this while the video continues. Okay, so I had to make some changes. You'll notice here that this is 48,194 objects instead of 480,000. It was taking way too long to do the full image. And so I'll show you what I did. I got a subset of the image and did it for that. So I'll add that in here and I'll show you what it looks like. So I'm going to add in the full image first, and I'll add in my segments for the area I just did. And so you can see that I just did this area of the image. And I did it with about, I set the parameters to 50,000 for the slick. And so if I turn, we'll add the clipped image in now. And so that's the final area that I'm going to work with now. Just because it takes way too long. It was going to take 12 hours to run all those segments through. You can speed that up by parallelizing it, which I might cover in a future video. But for now, we're just going to have to deal with this smaller area. Yep. So there you go. There you have it. That took 10 minutes to run those 50,000. I'm not sure why it was taking so much longer, actually, because the image is a lot larger. And it takes longer to index. So this part right here, when you have that image, it takes a lot longer to index it. If you could split this up and do certain parts of the image at once, it might speed things up. So there are ways to speed this up to deal with that full-size image, but for now, for this tutorial, like I said, I'm just going to deal with it by making the image smaller. And I'll have to go back and remake my training truth data set basically so that it's only for that image, and that's okay. I'll go back and do that, and I'll show you what it looks like when we get to the next video. But thanks for watching. Hope you're enjoying this series on object-based image analysis.